Okay, so the last 6 problems kind of combine a few things. Some are simplifying, some are rationalizing denominators. So when we look at one like 25, we want to decide, okay, is 64 a perfect cube? Yes, it is. So I'm going to leave that alone because I can take the cube root of 64. But then remember, when you look at exponents, if to be a perfect cube, an exponent has to be a multiple of 3. So when I see a to the 7th, 7 is not a multiple of 3, but 6 is. So I'm going to break this up into a to the 6th and a to the 1st. Now again, why did I pick a to the 6th? Because when I put this in exponential, or think about it that way, a to the 6/3 power comes out to a squared. So as long as that's a multiple of 3, this will be a perfect cube. And b to the 3rd is a perfect cube. That 3 is a perfect cube. It's a multiple of 3. Whoops, that's a b. So I leave that one alone. And again, what I do is I circle the things that I can simplify. So I know what I need to take out of the radical sign. Cubed root of 64 is 4. Cubed root of a to the 6th, again, 6 divided by 3 is a squared. B to the 3rd, cubed root of that, 3 divided by 3 is b to the 1st. So all you're doing is dividing. You're thinking of this divided by that. What I didn't circle has to stay under the radical, so I have the cubed root of a under the radical. All right, so you're just breaking these things up. When you're talking about powers and exponents, in order to be a perfect root, it has to be a multiple of that number. All right, so let's look at 26. 26, I look and I break, because it's a fraction, I would probably think of this as the 5th root of 32 in the numerator, 5th root of m to the 3rd in the denominator. Now, 5th root of 32, that comes out evenly. 32 is a perfect 5th root, it's 2. So I really have 2 over, the 5th root of m to the 3rd. So this one becomes one where I can't really simplify that. I can't take out any perfect fifths, but I can rationalize the denominator. So because this still doesn't simplify, the only other thing I need to worry about is getting rid of any radical in the denominator. So now you got to think about, what do I multiply this by to get to a perfect fifth? And remember, to be a perfect fifth, a power has to be a multiple of 5. So I'm going to multiply by the 5th root of m squared. Because now in the denominator, I'm going to get the 5th root of m to the 5th power. And that is a perfect fifth. So in the numerator, I have 2 5th root of m squared. In the denominator, I have the 5th root of m to the 5th. Again, I can simplify that. Think of m to the 5 divided by 5. So my numerator can stay the same. Denominator, I get m. All right, so that's if you can't simplify, but you still have something in the denominator. You got to multiply now to get that to be a perfect fifth. All right, let's look at 27. 27 is 162, square root. So I'm thinking of perfect squares that go into 162. So again, off to the side, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. So I'm trying to think of perfect squares that go into 162. And so I think I'm going to try, let's go, this was 8 squared, 9 squared is 81. I think 81 goes in there. And again, to get that, if you don't want to come up with this whole list, you can just think about, okay, let's just take 162 divided by 2. Oh, that's 81. That's a perfect square root. So I know it's 81 times 2. So however you get to that, you've got to come up with a perfect square that goes into 162. So you can do it by the list until you find the biggest one, or you can just kind of say, okay, I'll divide by 2, see if I'm left with a perfect square. Divide by 3, see if I'm left with a perfect square. For the m to the 5th, it's going to be the square root of m to the 4th, because again, that's now has to be a multiple of 2, and the square root of m. And g to the 6th is a perfect square because 6 is divisible by 2. So I always now, because I'm doing square roots, have to make sure that number is even. It's got to be divisible by 2. So I can simplify this, this, and that. So square root of 81 is 9. When I take this, m to the 4th, take the square root of it, 4 divided by 2 is 2, so m squared. Here, g to the 6th, the square root of that, 6 divided by 2 is g to the 3rd. What's left goes under my square root, a 2 and an m. All right, let's look at 28. 28. I'm looking at fourth roots of 48. I don't believe 48 is a perfect fourth. 2 to the 4th, though, and again, if you don't know, just use your calculator. Whoops, clear. 2 raised to the 4th is 16. Does 16 go into 48? Yes, it does. It goes in there 3 times. So I can break up 48 into the 4th root of 16 times the 4th root of 3. All right, now we're thinking of exponents again. It has to be a multiple of 4 to be a perfect 4th root. So x to the 13th is going to be x to the 12th and x to the 1st. 8 already is a perfect 4th. 8 is divisible by 4. 7 is not, but I can do z to the 4th and z to the 3rd. So the ones that I can simplify, anything where it's an exponent that's a multiple of 4, and then for the number, the 4th root of 16. So 4th root of 16 is 2. Here I get 12 divided by 4 is x to the 3rd. 8 divided by 4 is y squared. 4 divided by 4 is z to the 1st. What's left stays under the radical, 3x z to the 3rd. All right, number 29. 29, we're looking at cubed roots. So first of all, I guess you could try to simplify the cubed root in the numerator, but you'll notice in the denominator it's b squared, and I want to take the cubed root of it, so I know I'm going to have to rationalize. I would probably rationalize first. You don't have to. You could simplify the numerator, simplify this first. I'm going to rationalize the denominator first. So if I have a b squared, and I have to get to a perfect cube, it has to be a multiple of 3, so all I need to do is multiply by the cubed root of b to the 1st. Because now in the denominator, I get the cubed root of b to the 3rd power. The cubed root of b to the 3rd power is b. So let's multiply the numerator, put all that together. 16, c to the 8th and a b. Denominator, the cubed root of b to the 3rd is just b. Now we need to see, can we simplify it? So is there any perfect cube that goes into 16? So 2 to the 3rd is 8. Yep, 8 goes into there. So I'm going to break that up. Cubed root of 8 and cubed root of 2. I go to c to the 8th. It has to be a multiple of 3, so 6. So I'm going to do the cubed root of c to the 6th and the cubed root of c squared. B is just b to the 1st. Can't do anything with that one. All over b. Circle the ones I can do. Cubed root of 8. That 6 is a multiple of 3, and that's it. So I end up getting a 2. C to the 6th cubed root of that would be c squared. And now what's under the cubed root is a 2, a c squared, and a b. In the denominator, I still have my b that I rationalized earlier. All right, and then the last one. Same kind of thing with the last one. You can either try to simplify first or do that later. So I see again I have a k to the 9th, and I have to get that to be a multiple of 4. So I would probably rationalize first. So I'm going to multiply by the 4th root of k to the 3rd power. The reason I picked k to the 3rd is now I'm going to get k to the 12th in the denominator. So I'm going to rationalize the denominator first. So in the numerator, I've got the 4th root of 256 j to the 10th, k to the 3rd, over 4th root of k to the 12th. So in the denominator, I'm going to get k to the 3rd when I'm done. In the numerator, we have to simplify that. 4th root of 256. I have to think about perfect force now. I'm actually, because that's an even number, I'm actually going to try to see what the fourth root, if it comes out evenly. Because sometimes that number will just come out evenly. So let's do that. We'll do 4, math, down to the xth root of. So the fourth root of 256. And it does come out evenly. Fourth root of 256 is 4. And again, to get that, I typed in 4. I hit the math button. The math button's right here. So I hit the math button, and when you hit the math button, I went to the xth root of. And so I got the fourth root of 256 is 4. So that comes out evenly as 4 times j to the 10th. I need to break that up into something that's a perfect fourth, a multiple of 4. So that's going to be the fourth root of j to the 8th. And then I'm left with the fourth root of j squared. K to the 3rd, I can't simplify that any. It's already smaller than 4, so I can't break that up. And down here I can take that and get k to the 3rd. So the thing that I can simplify is just that one. So I'm going to have a 4, a j squared, because that's 8 divided by 4, fourth root of j squared k to the 3rd, all over k to the 3rd. Now, these do not simplify, because this one's under a fourth root and this one is not. So that's as much as I can do to simplify that one.